Introduction to limits. First of all, let's start with the objectives. Studying objectives. Use the definition of limit to estimate limits. Determine whether limits of function exist. Do you know why we have to study calculus? The most important subject in calculus is the limits. Up to now, you have used algebra and geometry to solve problems, where things are basically staying the same or changing at the same rate. Calculus is a branch of mathematics that deals with things that are changing. Volume of an expanding balloon, the rate of change at any point on a curve, and acceleration of rocket that is changing every part of a second. Definition of limit of a function. Suppose that the function f of x is defined for all values of x near a, but not necessarily at a. If as x approaches a, then if of x approaches L. So by the definition of limit of f of x as x approaches a equals L. Okay, I am going to use linear function to show you the definition of limit. By taking the linear function 5 minus 2x, taking values around x equals 1 as shown in the table, less than 1 and more than 1, then evaluate in the linear function to get f of x equals 3 less than or more than. This table helps you to understand the definition of limits. Now let's understand the left and right sides of the limit by looking onto this graph. By looking onto the cubic function graph, as x approaches 0 from right side or from the left side, the result is L equals 0. So according to this graph, the limit exists around x equals 0. And for this situation, if the right and left sides are the same, then the limit exists. Theorem. A function f of x has a limit as x approaches c if and only if it has left hand and right hand limits, and these one-sided limits are equal. If you apply the theorem on the graphs, you easily conclude if the limit about point exists or not. In graph number 1, the limit exists for all values of x. Graph number 2. The limit does not exist around x equals 15 if you apply the previous theorem. The left and right around x equals 15 are not equal, so the limit does not exist. Let's take another example. Graph number 1. The function f of x is a rational function, as you can see. Limit at x equals 1 exists and equals 2, even though the function is undefined at x equals 1, because the value 1 makes the denominator equals 0. Graph number 2. The value of function at x equals 1, but the limit as x approaches 1 equals 2 if you apply the left and right-sided limits. Graph number 3. The given function is a linear function, and then continues for all values of x. The limit exists for all values of x also. That's all about limits. I hope you all understood and take benefits as much from this video. Thank you for your attention. See you in next video. Ebrar Kadan.